Yes, I'm recording. Thank you. We have one little thing to learn, and it's new, and hopefully it makes sense, but it's kind of unrelated to the sign analysis, full-on sign analysis that we've been doing, but it's also is related. So it's like open-minded, ready to go. Here we go. Recall how we find an average rate of change. How do you find an average rate of change of something? Let's say we have the average rate of change of position from 1 to 4. What would you do to find the average rate of change? Tell your neighbors. If you're wrong, who cares? Yeah, good. If you were like, yo, don't we use the slope formula and we find the slope of the secant, you are right. Good. Okay, but now I'm going to ask you, what are some other words for the rate of change of position? Hey neighbors, what are other words for rate of change of position? I want all of the words. You guys are a lot better than the previous classes. Good. Here are the 3 words that I am looking for. Usually it's 2. Usually it's slope of a tangent, or slope, derivative. Third word is the velocity. That's like the physics word for rate of change of position. So this is velocity. Well, if we are calculating an average rate of change of position, I'm actually calculating an average velocity. So this calculation right here is an average rate of change of position, but it's also an average velocity because they're synonymous. Okay? And we could show the same thing for the average rate of change of velocity. Let's just pick a random interval 2 to 6 to find the average rate of change of velocity. We are going to find the slope of the secant of velocity. Cool? But same thing, if I ask you what are all the words for rate of change of v, you would say, oh, slope of v, derivative of v, or acceleration. Well, if I ask you what is the average rate of change of velocity, well, you'd say, well, that's the same as the average acceleration because they're the same thing. So this calculation is actually an average acceleration. Okay. Now, that's cool. We've got that set up. Here's really where the lesson starts. The top part of those fractions. Now, we, in all of our days leading up to today, have been all focused on a sign analysis. You know, it's like we got a derivative from a start to an end. I don't know what the signs are, but whatever. It'll tell me whether I'm going up or down and how much. And then we have this new layer that if I accumulate my derivative, I'll get a total amount that I go up or down, whether it's a positive number or it's a negative number. Cool. This can be found, and we did this on day 2 with the calculator. How did we find this number on day 3 without a calculator? What did you do? How did you find this number without a calculator? Say you're given your velocity equation. Here's my velocity is 2t plus 2. And I ask you, hey, between 1 and 4, what's this number? What do you do? Yeah, you need to use the antiderivative, right? And we kind of have seen this. We've done it. It makes sense with what we've been doing. You got to take the antiderivative. You got to understand that there is a plus c that we don't know, or we do. It doesn't matter. When we do the calculations, the c will go away. This is 3 plus c. This is 16 plus 8 is 24 plus c. And then we say if this is 3 plus c and this is 24 plus c, this has to be a total of 21. Cool. Now, what I need us to do sometimes moving forward is to be comfortable with getting this answer 21 without showing all of this work. You know, if I just ask you, hey, what's the accumulation of 2t plus 2 from 1 to 4? You first ask me this question. You should always ask this question from now on. What's the first question you should ask me if I ask you, what is this? Do I have a calculator this semester? That should be the first question you ask. Like, hey, this semester, can I use the calculator? Because if you could use the calculator, what would you do? Yeah, you just plug it in, and your calculator can accumulate. This is what the calculator knows this as. Accumulate this from 1 to 4. And you get your answer. Everybody type it in really quick. You get 21? All right, good. We got 21. Now, what if I say, no, you don't have a calculator. You're not allowed to use the calculator. What do? If I say, no, you don't have a calculator, what do? Don't say give up. You remember that the reason why we use this symbol, everybody focus. The reason why we use this symbol for accumulate is because we had to, as a human species, take antiderivatives for hundreds of years until the calculator was invented. Okay? So if I ask you to do this without a calculator, you're like, oh, let me use my antiderivative. Antiderivative being, you know, whatever it means. If this is a velocity, yeah, this is a position. Great, t squared plus 2t, and then we understand that you can find your final position, you could find your starting position, and what would you do with those two numbers? Subtract them, your ending subtracted by the beginning. Okay, and either way, you're going to get the right answer. So it's like I get 24 plus c. Here, if I plug in 1, I get 3 plus c. When you subtract them, you get what you're looking for. So here's what I need you guys to write down. That the accumulation of your velocity can be found using the antiderivative, your position at 4 minus your position at 1. And like, boom, yeah, we got 21 or 21. Calculator, no calculator. Calculator, type it in. You don't have to take an antiderivative. Your calculator can accumulate that velocity. No calculator, you have to take an antiderivative. Now, great, that's good. It's good to kind of remind ourselves of like what we're doing. It's good to remind ourselves of the fundamental theorem of calculus. The fundamental theorem of calculus equates accumulations with antiderivatives. Great, keep that in mind, but let's actually go back to finding this idea of an average of something. Go back up to the top. No giggles, please. I just found x of 4 minus x of 1. Right? I said that's equal to the accumulation of my derivative of my velocity. What we have now is another way to get the same answer. This average rate of change is equal to this accumulation divided by my interval. I could go further to show how v of 6 minus v of 2 is equivalent to the accumulation of A divided by your interval. Which will bring us to the key to the lesson. If I ask you to find the average of something, you can equate it to the average rate of change of something, but it's actually less complicated if you don't think about it that way. For example, I told you that the average velocity is the same as the accumulation of velocity over your interval. Cool? We just kind of said how that's the same as x of b minus x of a over b minus a. But we're just going to focus on this. And we could forget about this if we wanted to. We could just say, if you want to find the average of v, do this. Now, let's think about average from like middle school, when you're asked to find the average of a set of numbers. How do you find the average of a set of numbers? Tell your neighbors. Right. So you all nailed it. You add up all the numbers and you divide it by the amount of numbers. What's this mean again? Well, to your calculator, it means accumulate or add up. Let's add up all of our velocities over my interval and divide it by my interval. It's the same idea. Add up all your numbers, divide it by the total or divided by the interval. Is that cool? So now I can almost just be like, well, let's not worry about how velocity is the same as the derivative of position. It's like average velocity, I'm going to find the accumulation of velocity. If I ask you to find the average F, F can be replaced with anything. You'll just accumulate or add up all of your F's divided by your interval. Cool? If I ask you for the average acceleration, all right, we talked about that, but it's good to write it down again. We would add up all of my acceleration and divide it by my total. Which brings us to something that some students ask me, not every student, very similar to average F, an average position. Now, this isn't usually the question students ask me. The questions students ask me are like, Mr. Messner, why would we ever need to take the antiderivative of F? By the way, what do we say the antiderivative of F is? Capital F, right? Like, why do we ever need capital F when we usually have said like F, F prime, F double prime? Why would we need capital F? Well, let's say I ask you to find an average position, and I don't let you use a calculator. You don't have a calculator. You're asked to find the accumulation of all of the positions. How do you find an accumulation without a calculator? Tell your neighbors. So, ready? This is where we go off the rails a little bit. If you have space, write it here. I didn't copy this over. So if you have space on this page, write it out. If I want to find an average X and I don't have a calculator, well, I'm going to have to take the antiderivative of X. What's the antiderivative of X? Big X. and I'll have to plug in B, and I'll have to subtract big X with A plugged in. And this is why we like to stop talking about average rates of change being equivalent to averages, because it can be confusing. What this means is the average rate of change of the antiderivative of position. The average rate of change of big X is equivalent to the average position. Let's see if you're picking up what I'm putting down. Go to this question right now. This is the second question. And I say, hey, you have a calculator. Hooray! What's the average position if this is a position equation from 0 to 2? At least get a setup. Write down a setup. We're on the second question with the average position, and please change that 3 to a 2. Okay, go. Again, this is like a lot of students don't have a lot of confidence because like we've been doing the same stuff over and over and over and over again, just like different ways. But now this is new. So like try, and if you fail, it's okay. I know we're doing well. Most of us did very well in the last quiz. -0 to -1. Now, here's where some mistakes happen. We're used to like analyzing the signs of my derivative, right? Not here. You want to find an average of your position, sum up all of your positions. And it's okay if we made this mistake because we've been like taking derivatives all units. But I want to sum up my position and I want to divide it by like the amount or the interval. That's it. Okay, you have a calculator. What do? Yeah, plug it in. Everybody plug it in. Now, do I have to graph stuff in y equals? Do I have to use an integral with y1? No, we don't have to do a full sign analysis for this. Literally type this in, have your calculator add up all of your positions and divide it by 2 and get the answer, please. -2/3, sure. -2/3, cool. -2/3, great. Now, what if I said, oh, sorry guys, you don't have a calculator? Well, at least we know what the answer is. That's good. At least we know what the answer is. But now you don't have a calculator, and you're still finding the average position, and you still would like to accumulate all of your positions over your interval, divided by the time in which you're accumulating that. It's kind of like the idea of average. Add them all up and divide by the total. But how do you evaluate the guy on the top without a calculator? Tell your neighbors. You don't have to do a sign analysis. That's wrong. Okay. This is what I was trying to tell you earlier. We've been doing sign analysis all good, and sign analysis are great. But sometimes we can go straight to, oh, I can just do this. We don't have a calculator. How do I find this top part? How do I do an accumulation without a calculator? This is your hint, guys. This is your hint. Do it. Do it. That's your hint. Why have we been using an integral to accumulate? Because we had to take antiderivatives, which means we need a big X. We need 1/3 t cubed minus t squared plus c. Don't forget about your plus c's, even though they will go away. We need big X with 2 plugged in. We need big X with 0 plugged in. And we will subtract them to see the difference or see how much X has gone up or gone down. Put your phone away, Shab. No, you don't. I just did. You're not allowed to have your phone out during the lesson. Okay. I plug in 2. I get 8/3. I'll do it over here. Big X of 2 is 8/3 minus 4 plus C, but the C is going to go away. We know that. That's 8/3 minus 12/3, so that's negative 4/3 plus C. I plug in 0. Big X of 0. Oh, that's easy. That's just C. Now remember, what we do is our ending minus our starting so that I understand the change in between, whether it's a plus or a minus. So like, again, the sign analysis is out, but we need to like be okay with not using it. We do negative 4/3 plus C minus C. Again, you know that the C's are going to go away, and it's like, oh yeah, I subtracted 4/3. Don't forget to divide that by 2. And voila, that's how you get that answer the same way without a calculator. All right, let's see. I'm going to challenge you. Here's your challenge. Please don't wait for other people to do it for you. You can try to do it yourself. That's a great question, Noble. That's a phenomenal question. That should have been everybody's question. Hey, can we use the calculator? No, sorry. But you can check your answer with a calculator. Let's just attempt to get the right answer without a calculator, and then check your answer with a calculator. Wrong. Let me tell you what the real answer should be.
Acted like that's your calculator. Should be one. We're going to be great. Whoa.
Yes, the real answer you should get is 1/3. See if you can get 1/3.
I thought you said we didn't have a calculator.
What's up?
What's this?
I did. Depends on if you have a calculator or not. That's the key. Your calculator can accumulate. You can't. You have to take an antiderivative. Okay? That's the key. All right, ready? Here we go, because we got to move on. Ready? Let's see how we did. Let's see where we went wrong. I want to find the average position. Okay, an average position would be accumulating my position over my interval, dividing it by the interval. Okay? Kind of like our idea about averages in general. Great. Well, that means I need a position function. Great. I'm going to go ahead and take the antiderivative of v to get x. I get t squared minus 2t plus c. I have an initial position. Whenever I can find c, do it, because it will never hurt you. I'm going to go ahead and find my position function is t squared minus 2t plus 1. Okay, great. Well, that's what I'm trying to accumulate. Now, again, your question at the beginning should have been, Do we have a calculator or not? If you had a calculator, you're done. You type that into your calculator. You let your calculator accumulate your position and you divide it by 2. You will get the answer 1/3. I just told you you don't have a calculator. So what do you have to do? Not yet. You have to take the antiderivative. But you're like, well, I already did. Like, yes, you did to get x. But now to accumulate x, we need one more antiderivative. We need big X. Why do we need another antiderivative? Because that's how we have to accumulate position. Is we have to take an antiderivative, find the change to figure out how much my big X increases or decreases. Yes. Okay, so big X of 2 is 8/3 minus 4 plus 2 plus C. That's 8/3 minus 2. That's 8/3 minus 6/3, which is 2/3 plus C. Big X of 0 is just C. I have 2/3 plus C minus C. When I subtract the 2, divide that by 2, you get 1/3. Cool? So, great. Now, I'm going to throw this guy at you. And I will tell you, you can use your calculator or not, I don't care.
Anytime you have one accumulation.
When you don't have a calculator.
Okay, wait, is this with a calculator or without a calculator?
Doesn't matter for this one.
Wait, just wanted to ask.
You should be able to look at this question. You should be able to give it some thought, maybe do a little bit of work to get 1/3. What's your question?
So if we start with the we need to do the antiderivative.
Well, it depends on what I'm asking you for. If I ask you for the average velocity, then you need to accumulate your velocity. Okay. If I don't have a calculator, I have to take an antiderivative. I have to use position. Now, let's say I give you velocity and ask you for an average position. Well, you got to take the antiderivative to get your position equation. You need to accumulate your position equation, which you can do with the calculator easily. But if you don't have your calculator, you have to use the antiderivative, which means for that previous question, and only for that previous question, I had to go from V, antiderive to X. Since I want to accumulate X, I have to use big X. Don't memorize, just understand the average. This is what you're going to go with. From now on, guys, the average of something. Add up all of that thing. Divide it by your interval. Okay, that's what you're starting with. Can you start with that? The average of something, accumulate that thing, divide it by your interval. Cool. Ready? The next question is, do I have an equation for V? Do I have a calculator? Can I type this into my calculator to have my calculator just accumulate for me like you've been doing on your quizzes? I don't in this situation, but if I did, like, great, I'd use it. If I don't have a calculator, I would have to take the antiderivative. However, this is giving me all the accumulation. You don't have to look at X of 6 and X of 0. If you don't want to, you can literally just say, oh, -2 plus 6 minus 3 plus 1 is 2. 2 divided by 6 is 1. All right, let's move on. Go to this question here. We're going to move on to free response. That's not this one, it's the next one. It's the quicker one to do. Ready? Okay. Here's your key to free response, particularly free response justification. The first thing is less is more. What do I mean by that? A lot of students, when told to explain or justify an answer, will write a paragraph worth of information. Don't do that. Typically, the more you write, the more I have to read, which means the more attention I'm paying towards what you've written. And if you make one little teeny tiny mistake in there, boom, your point's gone. And this is the same thing for the AP graders. The more you write, the more we are going to try to nitpick what you wrote. And if you make one little mistake, boom, your justification's wrong. Less is more, okay? Remember, it's a calculus class, which means stick to your derivative analysis. Stick to things increasing or decreasing or signs being positive or negative. Don't write too much, though. We'll do a couple examples. Third, and this goes for everything, there's no naked answers. You can't just write down an answer and have nothing behind it. If you use an integral, you have to use an integral. If you didn't use an integral because like, oh, they gave me that this area is -8, this is 3, and this is -2. Like you just said, like I added -8 and 3 together. They're not going to accept that. You have to write, oh, I accumulated V from 0 to 5. Got that? Okay. This is the easiest problem to get through because we don't have to do much in terms of calculations. Let's do a couple of problems. And also, last thing, if you're not told to justify, don't, okay? Like, don't justify unless you're asked to. But make sure it's not a naked answer. Let's start. This one is a horizontal tangent, 4 is a horizontal tangent. Here are your accumulations. That's all stated in here. Let's skip A. Let's go straight to C. What is the acceleration of the particle negative? Justify your answer. Go. Give it a shot. What's the answer? And then what's your justification?
I'm kidding. I don't want to kick you out of your spot. Especially not sure you should stand there. He had his phone out there. Holding me.
Ready? The answer is 0 to 1 and 4 to 6. The intervals are worth 1 point. The following justification will be worth 1 point. Every free response question is worth a total of 9 points. A being negative, that's the second derivative sign analysis. 1 - 2 - 3 - 4 - 5 - 6 - 7 - 8 - 9 - 10 - 11 - 12 - 13 - 14 - 15 - 16 - 17 - 18 - 19 - 20 - 21 - 22 - 23 - 24 - 25 - 26 - 27 - 28 - 29 - 30 - 31 - 32 - 33 - 34 - 35 - 36 - 37 - 38 - 39 - 40 - 41 - 42 - 43 - 44 - 45 - 46 - 47 - 48 - 49 - 50 - 51 - 52 - 53 - 54 - 55 - 56 - 57 - 58 - 59 - 60 - 61 - 62 - 63 - 64 - 65 - 66 - 67 - 68 - 69 - 70 - 71 - 72 - 73 - 74 - 75 - 76 - 77 - 78 - 79 - 80 - 81 - 82 - 83 - 84 - 85 - 86 - 87 - 88 - 89 - 90 - 91 - 92 - 93 When A is negative, X double prime is negative. That means X prime is decreasing. That means V is decreasing. That's when velocity is decreasing. Now, really quickly, and it has to be stated more than once, you're not allowed to circle a sign analysis and say, here you go, there's my justification. You have to literally have a statement. The statement might be literally this, repeated, but that's it. What are some other justifications that accept? The derivative of velocity is negative. I'll accept that. I'll accept V prime is negative. What I won't accept is like A is negative. Like I won't accept that because that's what they ask you for. Okay, here, part C2. When is the particle moving left? Justify. Explain your answer. What's your explanation? No, don't say that. Just say velocity is negative, you know? Now, your explanation could go to this length. Your velocity is negative, means your position is decreasing, means you're moving left. Don't. Because a lot of you guys like to say it. Never say it. Never say it is negative. Did anybody say it is negative? Don't say it. That's number 5. Don't say it or the graph. Be specific. Don't say it. Don't say the graph. The graph could mean any graph. Like graph of what? It's like, oh, this graph. It's like, I didn't know you were talking about that. I thought you were talking about the graph of position. I thought you were talking about the graph of acceleration. I don't know. So don't say it. Particle is moving left from 0 to 3 and 5 to 6. Why? Because V is negative. Either you write that or you write V is negative with words. Okay, now let's go to part B. So the problem is, like, when you say the position is decreasing, that's just another way of saying the question. When is the particle moving left? So that's not you looking at a sign or a direction of something. I mean, it is like a direction of something, but this is the right sign. All right, what is speed increasing? Go. Let's just find the interval. I'll tell you what the justification should be. Don't wait to find the interval. Try it yourself. You got it. I mean, I feel like you guys want to be taught by Rod here. I mean, I don't know. Pump the brakes, man. Make sure Rod's getting everything. I know you kind of learned everything, but I don't know if you really mastered everything there, Rod, because you're not really doing great on everything. All right, good. For the distance one? Yes, I'll accept that. Okay, ready. Speed is increasing when your velocity values are getting further away from 0. That's when your velocity is positive and increasing, or negative and decreasing, or keep it simple, V and A have the same sign. Now, you don't have to do your full sign analysis of your first derivative and your second derivative. You can see when are my velocities moving away from 0. That means they're getting bigger in their value. We're either going left and going faster to the left, or we're going right and going faster to the right. It's 0 to 1, 3 to 4, 5 to 6. Great. Now, what I just did is not what I just wrote down. I did not do a full sign analysis for V and A, the first derivative and the second derivative, though you could. But this is the just easiest justification to say, and they typically don't like the velocity values are getting further away from 0. They don't like that. They like signs of derivatives. That's it. Now, A. This question, maxes and mins, are usually worth 3 of the 9 points of any free response question. Why? Because it requires the most work. But you've done this over and over and over again. I just need you to make sure you do the following, okay? So let's go ahead and break out a full sign analysis. Now, this won't count for anything, but it'll help you get the right answer. We know at time 0, our position is -2. So at time 0, the position is -2. This needs to be bigger. We got 3, we got 5. We got 6. We got our derivative that is negative and positive and negative. We got our accumulations, which are -8 and +3 and -2. Ready? We will find my position at time 3 is -10. My position at time 5 is -7. My position at time 6 is -9. Are we all cool with those positions? -2, -10, -7, -9. Yes, great. Now, if you say x of 3 equals -10, I give you 1 point out of the 3. Okay? Here's how you earn the other 2 points. I'm not even sure if I'd give you 1 point. 1, you have to explain the extreme value theorem in the easiest possible way. Here it is. My position is a min when the derivative of position is what? Equal to 0, probably safer to say changes sign, or an endpoint. This is showing that you understand where candidates for minimum come from. Next, you need to provide your position with all of the work that went behind them. What do I mean by that? You need to say x of 3 equals x of 0 plus the accumulation, and that gives you -10. You need to say x of 5, even though you know it's not the right answer. It's a candidate. X of 5 equals x of 3 plus integral from 3 to 5 under x prime. That's -7. Even though you know it's not going to be x of 6, you still need to provide the work to show the answer, and then you have exhausted all your candidates. Now you get 3 points. And when you do your homework, you will practice that. Your homework is 4 free response questions just like your test and some average value stuff.
Later, Mr.
Later. Later.